Hey everybody, welcome to our flipped lesson on Unit 1, Target 6. In this lesson we're going to be taking our numbers and we're going to be classifying them based off of number sets. But before we actually dive into our number sets, let me ask you a question. How many numbers are there in existence? If you were just to think of every number that there possibly could be, how many are there? Would you say 10, 100, a billion, a trillion, right? Where does it end? Well, it technically doesn't end. There are an infinite amount of numbers. This picture here is a cool bridge that reflects with the water and makes our infinity symbol there, that kind of sideways 8, right? But that brings us to a problem. Because if we have an infinite amount of numbers, well, how do we deal with them? How do we organize them? How do we group them to work with? I mean, just think about people. There are 7 billion people in the world, which that's a lot of people, but it's way less than infinity. Can you imagine if you went on Amazon to order something, and when you went to put in your address, you just had to say Earth? I mean, how would Amazon ever send you a package if all 7 billion people in the world were just grouped into one big group? It wouldn't work. That's why we have towns, counties, states, countries, all of the things that we group people into so that we know geographically where they're located, right? And that's really what number sets are. Number sets are just groups of numbers that we have organized in a way so that we can talk about them and work with them in a uniform fashion. Now, to understand our number sets, though, and the relationships that our number sets have, I think it would be actually helpful to talk about our geographic number sets, right? Our geographic sets of people, like where people live. Generally, when you're telling somebody where you live, you start off with, oops, got ahead of myself there, you start off with the town you live in, right? So since our high school's in Grays Lake, we'll just say our town is Grays Lake. I know some people are Gurnee and Round Lake and Haynesville, but for the sake of argument, let's just stick with Grays Lake here, right? And this is kind of our smallest area of location, our smallest group of where we live. Now, our town is inside a county, inside Grays Lake's inside Lake County. If you live in Grays Lake, you have to live in Lake County. There's no way you can live in Grays Lake and not be living in Lake County. But the reverse is not true. You can live in Lake County and not live in Grays Lake, right? So as we go from smaller to bigger, we can see that smaller fits into bigger. But just because you're in the bigger one doesn't necessarily mean you're in the smaller group. Let's take a look at our next level here. So we go from county to a state, right? We live in the state of Illinois. If you're in Grays Lake, you live in Lake County. If you live in Lake County, you live in Illinois. That is a guaranteed thing. It's impossible to live anywhere else if you're in the county that's in Illinois. The same thing that we saw before, the reverse is not true. There are plenty of places you can live in Illinois and not live in Lake County. So again, the smaller group to the bigger group guarantees that it's going to be part of it there, but the reverse is not true. Well, what comes after the state is the country you're in, right? And the state of Illinois is in the United States of America. It is impossible, again, to live in the state of Illinois and not be living in the United States of America. You just can't get around it. Well, where is the United States of America located? Well, it's located on planet Earth, right? There are 7 billion people, and a good number of them live in the United States there. And it's impossible to be on any other planet, Mars, Pluto. Well, Pluto's not a planet anymore, I guess. I think that was a raw deal for Pluto. But, right, if you live in the United States, you have to live on planet Earth. There's just no other way around it. You can't be living on any other planet. However, there are lots of people, lots of places on planet Earth that aren't the United States, right? So someplace like Australia, they live on planet Earth, right? But every single person in Australia is not living in the United States, is not living in the state of Illinois, is not living in Lake County, and it's not living in Grays Lake. It's a group, a geographic group of people that has nothing to do with the first 4 groups we looked at, our town, our county, our state, and our country, the United States. Right? But we take the people in the United States and all the people that aren't in the United States and put them together, and we get planet Earth here. Our number sets, there's going to be 6 of them, just like we had 6 geographic sets here, are going to relate with each other in a very similar fashion to the way these groups of people, these geographic groups, related to each other. So let's jump right into our number sets here. Our first number set is the natural numbers. Now, the natural numbers, we kind of think of them as counting numbers, because these would have been the numbers you first learned about when you were learning how to count back in kindergarten. We start at 1, and we just go up. 2, 3, 4, 5, 6, 7. Where do we end? Well, again, infinity. There is no end. We could always find one more number that we could count to, starting at 1 and going up. Notice there are no negatives, no fractions, no decimals, and no zero in the natural numbers. The natural numbers are kind of like our town. They're our smallest number set. They're our smallest group of numbers. Now, just the same way that the town fit inside Lake County, our natural numbers are going to fit inside of our whole numbers. We can see that a whole number is the natural numbers, all of them, and 0. So we can see now that the natural numbers are inside the whole numbers, but the whole numbers are a little bit bigger. We have another number in there. We have 0. Still, again, though, there's no negatives, no fractions, no decimals. So we have the natural numbers going into the whole numbers the same way everybody living in Grayslake is in Lake County. The next set is the integers. Now, the integers are the natural numbers. We can see them being built in. They're opposites and 0. So as we look at our number line here, now we see a lot more options here. We still have our 1, 2, 3, 4, 5, 6, 7 up to infinity. Now, though, we have the opposites of those numbers, -1, -2, -3, all the way down to negative infinity, and we are including 0. So you can see all the numbers in the natural numbers and all the numbers in the whole numbers are inside the integers, just the same way the people that live in Grayslake are inside Lake County, and all the people who live in Lake County are inside Illinois. Integers is like our state. Notice still, though, we have no fractions and no decimals in these first 3 number sets. Those are not living in these number sets yet. So let's talk about the next number set is our rational numbers, right? Now we're actually going to start talking about numbers which can be written as a fraction, right? And the rational numbers here are like the United States. Well, you might be asking, how do we get all of the other number sets, the numbers from the other numbers, into the rational numbers if they're written as a fraction, right? None of those numbers with the points on the number lines up there look like fractions. Well, we actually can always write a number as a fraction by putting it over 1. Like 5 here can be written as 5 over 1, written as a fraction. We could also write a number as a non-simplified fraction, like -3 can be written as -9 over 3. That would be a fraction which would equal -3. So we can take any number in the natural numbers and the whole numbers and the integers and write them as a fraction. But there are going to be some numbers that weren't in the 3 previous number sets because the rational number set is bigger, just like the United States is bigger than the state of Illinois. We're going to have fractions and some decimals. Now, you might be asking yourself, how do we know if a decimal can be written as a fraction? Well, there are 2 ways to know this. The first is to look at a fraction like 5 over 2. Now, when we put 5 over 2 in the calculator, the decimal gives us is 2.5. And that is what we call a terminating decimal, right? Arnold Schwarzenegger shows up, hasta la vista, baby, and he terminates all of the decimals that would come after 5. They're gone. They don't exist. 5 is where our decimal ends. If the decimal ends, if it terminates, it can be written as a fraction. Well, the other option is a decimal that looks like this. We can see 1/3 is going to equal 0.33, and that little bar over top of it means that it's going to keep repeating that pattern over and over again for infinity. So it'll be 0.3333333333 forever. And we call this, by obvious reasons, our repeating decimal. So we know that a decimal can be written as a fraction, meaning it's a rational number, if it terminates or it repeats. One of those two it comes to there. Okay, we've reached halftime now. You've listened to me talk for long enough. Here's what I want you to do. And you're probably never going to hear another teacher outside of a flipped lesson tell you this. I want you to take a half an hour, that's 30 minutes, and I want you to get away from this video. I want you to go play video games, go watch a movie, TV show, get something to eat, run around outside, take a nap, whatever you want to do. But in 30 minutes, you need to come back and unpause the video because we still have some more stuff to learn about with our numbers and our number sets. So ready? 30-minute break. Ready? Pause. Hey, welcome back. Hope you had a good halftime. Hope you enjoyed whatever you were doing. Let's go back to our number sets now. We've talked so far about our naturals, our wholes, our integers, and our rational numbers. They're town, Grayslake, our Lake County, state of Illinois, and the United States. Now let's talk about our irrational numbers. Irrational numbers are numbers which cannot be written as a fraction. This number set is kind of like Australia. The people that live in Australia have absolutely nothing to do with the people that are living in the United States, in Illinois, in Lake County, and in Grayslake, right? So how do we know if a number cannot be written as a fraction? Well, we kind of take the same way we did with our rational numbers, but in reverse. Irrational numbers have non-terminating, meaning they never end, and non-repeating decimals. So they never end and they never repeat. One famous example of this is the number pi. Now pi is 3.14159265, and you can read the rest. And it goes on for a really long time. How long? Well, to this point, computers have calculated over 1 trillion, and they might even be over a couple trillion by now, decimals after 3 point and then 1 trillion or more numbers, right? They've never found it end, and they've never found it to repeat. So that's what makes pi an irrational number. We'll look at a number of different examples in our activities and some worksheets and stuff, but just make sure we understand that our irrational numbers and our rational numbers are completely separate groups that have nothing to do with each other. Well, what happens here, and as we said, we found they don't have anything to do with the previous sets of groups, as we said. So what happens now if we take the rational numbers and the irrational numbers and put them all together? Well, we're going to get the real numbers. The real numbers are all the numbers in the rational and irrational number sets combined. This is like planet Earth. If we take all the people who live in the United States and all the people who don't live in the United States and put them together in one big group, we get everybody, right? Now, the best way to understand the real numbers is maybe with a little diagram here. So let's take a look here. In this diagram on the left, we have our 4 number sets that we're familiar with that have a relationship with each other. We have the natural numbers, which is our Gray's Lake, our smallest number set. All of those numbers fit inside the whole numbers. It's a little bit bigger. All of the whole numbers then fit inside the integers. That's our state, right? So we go Gray's Lake, we go Lake County, we go Illinois, and then Illinois fits inside the rational numbers. Notice each number set is a little bit bigger than the one before because each number set here adds numbers that the previous one didn't have. Now, once we've got these 4, we still have Australia, right? Our irrational numbers. Notice everything that would fall in that category there, in that box, has nothing to do with the 4 boxes previously. There's no relation, no direct relationship there. The only time that these two have anything to do with each other is when we talk about the real numbers. When we take all of our numbers that we know and put them together, we get the real numbers here. So everything that would fit anywhere in this big rectangle here is considered a real number. So those are our 6 number sets. There are a couple more, some that are actually bigger than the real numbers, but we're not going to get in those today. We're just going to stop at the real numbers. That's where we'll work for pretty much most of the year in algebra. So now that we've kind of talked about our number sets, let's actually dive into doing some classification. So we have a list of numbers here, and what we're asking you to do is to come up with all of the number sets that these numbers would belong to. In other words, where do these numbers live? Which number sets, which groups do they live in? Let's do the first one together. Let's look at 8. So we start with our smallest number set. Is 8 a natural number? Well, yes, that would be in our counting numbers. 1, 2, 3, 4, 5, 6, 7, 8. So it's a natural number. Now, since I know it's a natural number, I also know it's going to be a whole number. Since it's a whole number, I know it's inside the integers. And since it's an integer, I know it's inside the rationals. Since it's a rational number, since it lives in the United States, it also has to live on planet Earth, making it a real number. So this number is a natural, whole, integer, rational, and real number. Now that we've done one together, why don't you try the other 5 here on your own? So go ahead, pause the video, and make a list of what you think, where you think each of these numbers lives. What number sets does it belong to? Ready? Pause. Great. Let's check our answers here. Let's see how you did. -5, you can see, is not a natural or a whole number because it's negative, but it is an integer, it's rational, it's real. 0 is not a natural number, but it is whole, integer, rational, and real. Now 7/2, that's a fraction, which means it can't be in the naturals, it can't be a whole, it can't be an integer, but it is rational because when you put it in your calculator, it's going to have a terminating decimal. That also makes it real. -4.18, repeating, right? Repeating decimal, we see that bar right there, that makes it rational, which makes it real. Now, the square root of 2, if you put it on your calculator, you're going to see it doesn't repeat. You don't see the same thing over again. And your calculator is going to cut it off, but that decimal would actually keep going forever, which is going to make it an irrational number or a real number. Notice every single number in this list has at least one number set in common. They're all real numbers. So that should kind of be a clue that you should be able to get one number set right when we're coming up these lists here. If you have any questions on these, please make sure you write them down and come to class with them tomorrow so we can work on them. Well, let's look at our numbers in a different way. Instead of just giving you a number, let's look at points on a number line here. So down below, there are 4 questions which are pertaining to the 5 points on this number line. So I want you now to pause the video and come up with an answer for each of these questions. And then when you come back, we'll look at the correct answers and see how you did. Ready? Pause. Welcome back. Let's see how we did here. So, which points are whole numbers? C, D, and E. We can see 0. We can see that's a 2, and that's probably going to be, what, 1, 2, 3, 4, 5, 6, right? E is 6. So those are all whole numbers. Those all fit in the whole numbers. Which points are integers? Well, now we can add B to that list. Right now that we can have integers, we can have negatives. But A, we notice it's going to be a decimal, not going to be in that list. So what number sets does point E belong to? Well, again, if E is 6, we know it's a natural, it's a whole, it's an integer, it's a rational, it's a real number. The last question, what number sets does A belong to? Now notice here, I said there's not enough information. Think about that. See if you can figure out why I would say that there's not enough information to know what number sets A belongs to. I guess other than the real numbers, right? We know it's a real number, but other than that, we don't really know what other number sets it could belong to because we don't have enough information. If you can't figure out why that's the case, make a note of that, come and let's ask that in class and we'll talk about that. Well, guys, we've reached the end. Well, just like Minecraft never seems to actually have an end or any point to the game at all, right? Our numbers have no end. They're going to continue on either up to infinity or down to negative infinity. So, until next time, guys, we'll see you later.